Today's topic is implicit differentiation. And first thing, if you remember, there's a couple different ways that you can notate that you have taken the derivative of something. So different types of notation. The ones we've used before are y prime, f prime of x. The prime tells you that you've taken the derivative. For implicit differentiation, we are using dy dx, which dy over dx signifies that you're taking the derivative of y with respect to x. So you're taking the derivative of y. So there's two different types of functions, explicit and implicit. Today, obviously, it's implicit differentiation, so we're really going to be using implicit functions. But we have been exposed to explicit functions so far, and we found the derivative of them. So an example of an explicit function would be y equals 2x to the third plus 3x minus 4. So we're going to practice using this dy dx notation to find the derivative of this, because this is something we're really comfortable with. So I'm taking the derivative of y. The derivative of y is 1, because it's just a constant. And whenever you take the derivative of a y term, you're going to stick a dy dx on it. This is 1 dy dx equals, okay, now I'm taking the derivative of the x term, so I'm not going to stick a dy dx on there, because I only stick a dy dx when I'm taking the derivative of a y term. So this is just going to be 6x squared plus 3, just like normal. So moral of the story, whenever you're taking the derivative of something involving a y, you're always going to put a dy dx in there. An example of an implicit function would be x squared plus y squared equals 10. So an implicit function is where your y term is not isolated. So let's take the derivative of this. The derivative of x squared is 2x. The derivative of y squared is 2y. But remember, whenever you take the derivative of something involving a y, you need to stick a dy dx in there. And then the derivative of 10 is just 0. I'm trying to solve for dy dx. That is the goal of implicit differentiation. I'm trying to solve for dy dx. So first thing I need to do is get rid of my 2x. So I'm going to subtract 2x from both sides. And then I'm going to divide both sides by 2y. So I'm left with dy dx equals, the 2's cancel out, so I'm left with negative x over y. So the derivative of y with respect to x, that's what dy dx means, is negative x over y. So to outline this process, you have 4 steps. The first step is you're going to differentiate both sides of the equation with respect to x. So remember, if we have something involving a y term, so 3y squared, you're going to take the derivative 6y, but remember you always have to stick on a dy dx, because you're taking the derivative of y with respect to x. So if I have something with just an x term, well, if I'm taking the derivative of x with respect to x, that would be like me saying this is 15x squared dx, but dx over dx is just 1, so I don't really even have to write it. That's why it's just 15x squared. Okay, so I differentiate both sides of my equation with respect to x. Remember to stick a dy dx on anything that has a y in it when I take the derivative. And then I'm going to collect all the terms involving dy dx on one side of the equation and move everything else to the other side. So I want to isolate dy dx, so basically anything that doesn't have dy dx, I'm going to move to the other side of the equation. Then I'm going to factor dy dx out of that side of the equation where I've collected all of my dy dx terms. And then I'm going to solve for dy dx by dividing both sides of the equation by whatever I factored out that doesn't contain dy dx. Alright, here's our first example. We're going to find the derivative with respect to x of 3x squared minus 2y squared plus 3y equals 4. Alright, this is with respect to x, so I don't need to write the dx. This is just 6x The derivative of negative 2y squared is negative 4y. Because it has a y term, I'm going to stick a dy dx in there. Then the derivative of 3y is just 3. But remember, I have a y term, so I'm going to stick a dy dx as well. And then the derivative of 4 is 0. Alright, I'm trying to isolate my dy dx terms. So I need to get rid of the 6x. I'm going to subtract it from both sides. So I'm moving everything that doesn't have a dy dx onto the other side. Alright, now I have only things with the dy dx on the left side, so I can factor a dy dx out of both of those terms to get negative 4y plus 3 equals negative 6x. Whoops, dropped my pen. So I factored out dy dx, and now I'm trying to solve for dy dx, so I gotta get rid of the negative 4y plus 3. I'm going to divide both sides by negative 4y plus 3. And that leaves me with dy dx equals negative 6x over negative 4y plus 3, or you could have reversed it. Not a big deal. Pause your video, try this one on your own. Copy it down into your notes. Try this one on your own. Alright, derivative of x squared is 2x. The derivative of negative y cubed is negative 3y squared. Remember to stick that dy dx on there because it has a y in it. The derivative of y is 1, so it's just 1 dy dx. The derivative of 5 is 0. I'm trying to isolate my dy dx's, so I'm going to subtract 2x from both sides. Now I want to factor out dy dx from both terms. Get dy dx minus 3y squared plus 1 equals negative 2x. And I'm trying to solve for dy dx, so I need to divide by negative 3y squared plus 1 on both sides. So my final answer is dy over dx equals negative 2x over negative 3y squared plus 1.